Start at the beginning. I notice that this is problem 11.
Well, I'd already done part of the packet.
That's fine. I'll start anywhere you want me to, Lachlan. You tell me where.
Yeah, we can just work on this for now.
Okay. What's the first step on A?
Subtract 3.
Okay. What's the next step after that?
Multiply by 2.
So that's going to leave us this. Don't usually do two steps in one, but now what's the next step?
Square root both sides.
So what's the next line?
X plus 2 is equal to plus minus 2.
Good. And what's the solution?
X is equal to 4.
Well, the way to do this is to move the 2 over.
Whoops.
Leave your plus minus 2. And now figure out what both numbers mean. In other words, using the plus, I get 0. Using the minus, I get minus 4. So those two should be my answers. Now, since it says be sure to check for extraneous solutions, there's probably a reasonable likelihood that one of these doesn't work. So let's test them. About 0. Does 0 work?
No.
Actually, it does. 2 squared is 4. 1/2 times 4 is 2. 2 plus 3 is 5. You sound puzzled?
No, I realize what I did.
Okay. Does minus 4 work?
No.
Okay. You must be having a little problem plugging these in. So I'm
just
going to plug in minus 4. Okay. And I'm plugging it in only for x. Now, the question is that still a proper equation? Well, this in the middle is minus 2 squared is plus 4. 1/2 times plus 4 is 2. 2 plus 3 is 5. So yes, it does. Both solutions work. But I'm betting that most of the rest of these problems on this page, one of the solutions does not work. So you need to get good at plugging them in to check them. Okay. How about number B? What's the first step on B?
Add 7.
Okay. So that becomes 16. And now what does that mean? Absolute value of 3x plus 4 equals 16. That actually always means two things. What's the first thing it means?
I'm not sure.
First thing it means is always the exact same thing, just take away the absolute value sign. So that's the first thing it means. The second thing it means, and I write this horizontally because I'm going to have two equations that I got to solve. The second thing it means is the stuff inside the absolute value is equal to minus 16.
Okay.
Now, if I solve both of these equations, I get x equal 4 on that one. On this one, I get x equal minus 20 divided by 3. Now, absolute value problems are ripe for extraneous solutions. So we definitely want to check both of these. Does 4 work? Hold on a second. Let me erase that. So plug in 4 for x. Is that still an equation?
Yes.
Okay. Check mark. Plug in minus 20 thirds for x. Is that still an equation?
Yes.
Correct. Okay, let's go to number C. First step on C.
So, boo. Would you?
I'm actually glad you said almost subtract 1, because that normally would be the first step. But when you see radical signs in an equation, the goal is to isolate the radical sign. And it's already isolated. So we don't have to do anything to isolate that radical sign. So what is the first step?
Would you have to get all the x's on one side?
No, when you see radical signs, parentheses, exponents, denominators, get rid of them. That's the
So
first
would
rule of thumb. Let's get rid of that radical sign. How do I do that?
square it?
Okay, square both sides. What's the left side become? You know what the right side becomes. The right side becomes that. That's easy. What's the left side become?
2x squared plus 2?
Here's what I'm doing. I'm squaring that. What that means is 2x plus 1 times 2x plus 1. That's what that means. You have to FOIL it.
Okay.
What's the first term going to be? This times that.
4x squared?
What's the second term going to be?
2x?
What's the third term going to be?
2x?
Both of those add to 4x. And what's the last term going to be?
2.
It's 1 times 1.
Oh, 1. Oh my.
Okay. So that's what the left side is. 4x squared plus 4x plus 1. Now, what is that whole thing going to be? What's it called? It's quadratic.
Yeah.
How do we solve a quadratic?
With the square thing?
No, that's the hard way to do it. First thing you want to do is see if it's factorable. But in order to see that, you got to get everything on one side and 0 on the other. So when you see that you have a quadratic equation, know that that's always the first step. Is let's get everything on one side. Well, I already got the 4x squared on this side, so I'm going to bring everything over to the left. This becomes minus 4x, and this becomes minus 3. And that is equal to 0, because that's what's left on the right side when I move that 8x and 4 over. Now, it's always worth a shot at factoring them, because that is by far the easier way to solve it, rather than to go to the quadratic formula. So can you factor that? Let's give it a shot. How would you break up the 4x squared? What's the most likely way to break it up?
4x and x?
We can do that, but I don't know the answer yet. But what I tell everybody is break it up into factors that are closest together. And those two are closer together than 4x and x are.
Okay.
Now, what are both signs?
-4.
Just figure out both signs first. Don't figure out the numbers yet. Both signs
Minus.
have to be opposite.
Okay.
Because
And then
that's the only
4.
way you can produce a -3 is if both signs are different. If both signs were the same, that would be a plus whatever. Okay. Now, I can try 3. There's not very many factors of 3. 3 and 1. That does produce the middle term, doesn't it? That's -6x. That's plus 2x. Add them together, you get -4x. That is our middle term. So we factored it correctly, kind of accidentally, just going based on usually the factors are the two closer factors. Just the way Colorado does their math problems most of the time. Now solve that. Now that we got it down to this item times this item equals 0, how do I solve for x?
X is equal to 3/2 and -1/2.
Okay. Again, since this has a radical in the problem, I'm definitely checking for extraneous solutions. Eventually, we're going to find one where both of these don't work. If I plug in 3/2, I get 3 plus 1. Is that equal to the square root of 12 plus 4? True statement?
Yes.
Okay. If I plug in -1/2,
Wait, wouldn't it have to be 2x minus 4 and 2x plus 1? Or 2x plus 4 and 2x
this
minus.
right here.
Yeah.
Yeah. No, I erased it all, so I don't know. I don't remember what we had, but I think I had it right. Oh, excuse me. I substituted it. Oh, we don't need this written. That was the previous problem. Okay, we're plugging into this right here. When I plug in 3/2, this becomes 3 plus 1 equals the square root of 12 plus 4. True statement. So 3/2 works. Now plug in -1/2. What's the left side become? What's that become when x is -1/2?
It would.
What's 2 times -1/2?
-1.
Okay. Plus 1 becomes 0.
Yeah.
Now the right side is 8 times -1/2 plus 4. What's 8 times -1/2?
-4.
Plus 4 is 0. So yeah, second one works also. That's all we have to do to check for extraneous solutions is make sure that the equation remains an equation with both of your solutions. Sometimes they won't be, and you'll have to cross out the one that doesn't work. On D, first step,
You would subtract 18.
okay, that becomes -27. Second step,
You would divide by -3.
okay, becomes 9. Third step,
Square root both sides.
Okay, the left side becomes 2x plus 1. What's the right side become?
2x plus 1 equals minus 3. Oh, 3 and minus 3.
Okay. Now that means 2x equals 1 plus or minus 3, which means x equals 1/2 plus or minus 3/2. So what are my two solutions for x?
So x would be equal to 1.
No.
Oh,
One solution comes from using the plus, the other solution comes from using the minus. So what's 1/2 plus 3/2?
4/2.
Which is what?
2.
What is 1/2 minus 3/2?
Minus 2/2.
Which is minus 1. Always simplify. Don't give me answers like minus 2/2. Your teacher will knock points off that, I guarantee you. When you can simplify something, you're always supposed to do it. Okay? So now let's check this one. I don't need any of this work except my two final answers. And let's plug them in and try it. When x is equal to 2, what do we have? Spell it out for me. First step, you just want to substitute. That's all you want to do. You don't want to do any math in your head.
So 2 times 2.
Okay.
Plus 1 squared plus 18 is equal to minus 9.
Okay, now working from the inside, we have 4 plus 1 is 5, squared is 25, times minus 3 is minus 75, plus 18, is that equal to minus 9?
No.
No, that's an extraneous solution. Now, I'm a little suspect that we maybe did our arithmetic incorrect, but if the second solution doesn't work, then we're maybe in trouble. I'm just substituting that number, and then I'm going to do all the math afterwards. Okay, now we have minus 2 plus 1, which is minus 1, squared, which is 1, times minus 3. That becomes minus 3 plus 18 equals minus 9. No, that doesn't work either. You don't see many of these problems. No. I feel like I made a mistake. Let me just do this math in my head really quick. We had 2x plus 1 squared equals to 9. What did I come up with the first time? I think 3? It's 9, because this becomes minus 27 divided by minus 3 is a positive 9. No, that's the way I did it the first time too. And that means that 2 wouldn't work. How did I get 2? 2x equals, I left off the minus sign from the 1. That's why I'm having problems. So x equals minus 1/2 plus or minus 3/2. Yeah, I made a mistake in my math. X equals 1 or x equals minus 2. So a good lesson to learn there is if you come up with two answers and neither one of them works, probably a good indication you made a mistake in your math. Okay? Now, if I try these, what do I get? Minus 3 times 2 times 1 plus 1 squared plus 18 equals minus 9. This the same way? No, it's not the same thing. That's 3 squared. So that's minus 27 plus 18 does equal minus 9. That solution's valid. Now let's try the minus 2. Minus 3 times 2 times minus 2 plus 1 squared plus 18 equals minus 9. Working from the inside out, I got minus 3 squared is plus 9, so that's minus 27 plus 18 equals minus 9. Both of them work. So, very important lesson learned there. I was really shocked that neither solution worked. I was shocked enough that I was pretty convinced I had made a mistake. And I went back and redid the problem from the start and realized I had made a mistake. And both solutions work. They rarely give you problems that don't have a solution. So when you find no solution, be careful. It most likely means you made a mistake. Not always. But in this problem, that was certainly the case. All right, number E. First step.
Subtract 10.
Second step.
Divide by 3.
Third step. What's the third step? And then give me the next line.
So square both sides.
Okay. So what's the next line?
And you get 100 is equal to 4 minus x.
So what's x equal to?
Minus 96.
Huh? And is that the only answer? Yeah, we never at any point took square root. So we only have one answer to check. Does that work?
Yes.
Yes, it does. That becomes square root of 100, which is 10 times 3 is 30. 10 plus 30 is 40. So that's as basic as they come there. All right, next one. First step.
Get rid of the radical sign
By
squaring both sides.
give me the next line.
33 minus x is equal to x squared minus 3x minus 3x plus 9.
What are we looking at?
A quadratic.
How are we going to solve it?
By
We're going to get everything on one side.
Oh yeah.
What's going to be on the other side?
0.
Okay, so which side are we going to get everything on?
The right.
Okay. There's only one x squared anywhere. Now, how many total x's do we have? That's minus 6x there. Got to move that x over. What's that going to give us?
X squared minus 6x minus,
We're combining all the x's at this point. We've found all the x squareds. Now we're combining the x terms. When I combine the 2 on the right, I got minus 6x. I still got a minus x over here that has to be moved over to the right.
oh, minus 7x.
I move it over by adding it. See that?
Yeah.
Okay. Now what's the number going to be?
24.
Plus or minus?
Minus.
Now, can you factor that?
So x, and then plus and a minus, and then it would be minus 8 and positive 3.
Good. So the two solutions are x equal minus 3 and x equal 8. And now let's check those solutions. When you see a problem like this, I always expect a solution not to work. And I can tell which one's not going to work immediately. This one. Why? Because when you take the square root of a number, you always get a positive answer, 100% of the time. Well, when I plug in minus 3 for x, the right side becomes minus 6. That's impossible. So that one's no good. Now 8 at least gives me positive numbers on both sides. Now I got the square root of 25 equals 5. Yes, indeed. Good. Now, when I said that these look like the kinds that have extraneous solutions, it was because I had an x in the radical sign and I had an x outside the radical sign. That always presents problems. By problems, I mean be extra suspicious for extraneous solutions. All right. Another absolute value, but this is an absolute inequality. One thing you have to know here. That means two things. What are they?
X is greater than 10 and x is greater than negative 10.
The second part, you change both the direction of the inequality, so it's less than, and the sign on what comes next. So that's the way you handle absolute values and inequality. This is very straightforward. This is just like same exact thing, only remove the absolute value sign. But this, you got to do two things. You got to change the direction, and you got to change the plus or minus sign on the number. And that becomes your answer for my problem. And I just did that to illustrate how we're going to do all of these absolute value problems. So what does this mean? Give me the two things that means. A.
Which one? A? 3x plus 5 is less than 13. or 3x plus 5 is greater than minus 13.
Perfect. Now you just have two inequalities to solve. Solve the one on the left.
3x is less than 8, and then divided by 3.
Keep going.
X is equal to 8 over 3.
X is less than 8 over 3.
Oh, yeah.
And the or part?
3x is greater than minus 18 divided by 3. So x is greater than 6.
Negative.
Minus.
Now it says show on the number line. So here's our number line. I'm going to call that 8/3. I'm going to call that -6. And either it's less than 8/3 or it's greater than -6. So it should be that area on the number line. Hold on a second. Laughlin, my TV went off. I got to go turn it off. 1 minute. Be right back. All right. Now, there's some funny things about this problem. You still there?
Yeah.
That looks like the apparent solution. But then I start thinking, well, if x is less than 8/3, doesn't that go all the way to -infinity? Or x is greater than -6, goes all the way to positive infinity. Could this thing be true for all x's? Well, I don't know, to be honest with you. I'm inclined to think that this is the solution. How can we tell?
You have to test it.
Yeah, let's take a number that's outside of this. If it works, then I'll know this is the answer. If it doesn't work, I'll know this is the answer. So pick a number outside this range.
4.
Okay. Is that a true statement? When you substitute 4 for x?
No.
No, it isn't. So therefore, it's not this bottom one here. It is the top one. The only answers that are going to work are numbers that are between -6 and 8/3. And incidentally, there's zeros at both ends here. Not closed zeros, but open zeros. Meaning -6 doesn't work. -6 would give you 13 is less than 13, which is not a true statement. In other words, it can't be -6. And it also can't be 8/3. It's got to be between them. All right. How are we going to do B? Now we're getting into some harder ones. Same question. What are we looking at in B? It's got an x squared term, it's got an x term, and it's got a number.
A quadratic?
That's a quadratic. Well, these are going to be harder, but we're going to solve it basically the same way. we're going to get everything on one side, 0 on the other. So when I do that, I get this. And hopefully this factors. It does. You want to try, give it a shot at factoring that?
It would be...
Just do it step by step. Break up the 2x squared.
2x and x.
Next step, both signs.
Plus and minus.
Only in this case, that is a different plus minus than the top one. So I have to allow for both of them. What factors of 4 are there? There's 4 and 1. There's 2 and 2. Which ones would we normally try? Yeah, normally I would try 2 and 2. But I can instantly see that that's never going to get me up to 7. There's only one way I'm getting to 7, and that's if I have a 4 multiplying that 2. And I need to get up to -7. So almost certainly that's got to be 4. That would mean that's 1. Does that work? Well, when you're doing these kind of quadratics, you kind of have to use the double smiley face to even figure out if it works. In other words, it's part of the process. Bingo. So we factored it correctly. Let me erase everything that doesn't belong. Okay.
I'm confused though. Is that 2x plus 1?
Uh-huh. And x minus 4.
But how does that get to -7?
Well, multiply the insides. It's plus 1x. Multiply the outsides. It's minus 8x. Add those two together.
Okay.
Okay. Now, the problem still isn't solved, not by a long shot. This is not an equality. So it's not as simple as saying I'm going to set the left term equal to 0 and solve, and then I'm going to set the right term equal to 0 and solve. It doesn't work like that. The way you have to solve these quadratics that are part of inequalities is to draw a line chart and figure out the critical points, which is going to be wherever one of these things is 0. And this works whether you're multiplying or dividing. If I'm dividing a linear term by another linear term and it's greater than or less than 0, I got to use the same exact process. But the first thing is, give me my critical points, which would be your solutions if it was equal to 0. So what are your critical points?
-1/2.
And?
4.
Okay. Now, I'm going to plot those without 0 being on there. I don't want 0 on there. Now, what I need to do is figure out that when I'm to the left of -1/2, what do I have? Do I have a positive number or a negative number? So pick a number to the left of -1/2.
-2.
Okay. When you plug in -2, this term here is negative, correct?
Yep.
When you plug in -2, that term is negative. Negative times negative is positive. That's greater than 0. Everything to the left of -2 is positive. Now, pick a number between -1/2 and 4.
0.
Okay, when you plug in 0, the left term is what? Plus or minus. You don't need the exact number. You just need to know whether it's plus or minus.
Close.
The right term?
Minus.
Plus times a minus is a minus. That means everything in between those two numbers is minus. Now pick a number to the right of 4.
5.
You plug in 5, that's plus, plus times plus is plus, everything to the right of 5 is plus. Now we're ready to choose our solution. We need that to be greater than 0, which means plus. So our solution is there and there. Or if I'm writing it on a number line, I might write it like this. And it's greater than only, so it's an open dot going in that direction all the way to negative infinity, and at plus 4, also an open dot going that direction all the way to positive infinity. So this is one way to graph it, and you'll notice that matches what I did when I did my line chart exactly. But the key is whether it's greater than 0. Sometimes you'll have a less than 0. So the solution set that you're looking for is your negative signs, not your positive signs. Okay? So that's the way you handle inequalities that involve a quadratic. Or for that matter, if I had something like this, I would have to do exactly the same thing. If I said x plus 1 over x minus 1 is less than or equal to 0, got to do the same thing. My critical points are minus 1 and 1. Draw a line chart. I put minus 1 on it. I put 1 on it. When I do minus 2, I got a negative divided by a negative. That's positive. When I do 0, it's negative. And when I do plus 2, it's positive divided by positive. That's positive. So whether you're multiplying two linear factors or dividing two linear factors, you have to use this line chart. And the first step on the line chart is to figure out these critical points, which is wherever the numerator or the denominator is equal to 0. Okay. What does number C mean?
It's 10 minus 3x is greater than 2, or 10 minus 3x is less than minus 2.
Should we just go on? You know how to do this, right?
Yeah.
Let's do D. What are we looking at in D?
A quadratic.
Okay. So how are we going to arrange it, first of all?
Have to get everything over to one side.
Do it. Which side are you going to put it on?
The left.
Okay. That's the only x squared term we have.
X squared minus 8x minus 20 is equal to 0.
Uh-huh. Now, not equal to 0, it's less than 0. That makes all the difference in the world. If it's equal to 0, then it's just a straight factoring problem. But being less than 0 requires us to not only factor it, but do this line chart thing. So first of all, let's factor it. That's always a step.
So x and x, plus and minus, and then minus 10 plus 2.
Good. What's the next step?
Work out the critical points.
What are they?
-2 and 10.
And the next step.
Put them on the number line.
Notice that I don't label 0 on this thing. I don't really like the label 0. 0 is not a key point. If 0 was a key point, I'd put it on there, but it's not. Now the only thing I have to do is test to the left of -2. I got to test between -2, between the two numbers, and I got to test to the right of 10. So, what next?
Test on the left of
Okay, pick a number.
-3.
Okay. Now at this point, the only thing you have to determine is whether these are positive or negative. That's the only thing that matters. The term on the left becomes what? Negative or positive?
Negative.
Term on the right?
Negative.
Multiply it together?
Negative.
What's a negative times a negative?
Oh, a positive.
Okay, that means everything over there is positive. Pick a number between the two numbers.
0.
Term on the left?
Positive.
Term on the right?
Negative.
Combination?
Negative.
Pick a number greater than 10.
15.
Yeah, just a suggestion, pick the smallest numbers. I would pick 11. Just makes the arithmetic easier. But regardless of what you pick, that's positive and that's positive.
Yeah.
Which means those are all positive. Now tell me what the solution set is.
They're both going in opposite directions?
Remember what we're trying to solve for.
Oh.
It's less than 0. So what's our solution set? Less than 0 means negative. Greater than 0 means positive. So our solution set is all of those answers right there. -2 to 10, and only those. Anything outside of those two numbers makes the product greater than 0. And that's not what we're looking for. We're looking for less than 0. All right. Let's go do law of sines and cosines. At least let's start. This is not the only page that we're going to be dealing with, is it?
Well,
do we have more material for tomorrow's session?
Yeah, we have more material for tomorrow.
Okay. I just wondered how fast I need to move through this.
No.
Okay, so law of sines and the law of cosines. Most of the time, you're always starting with the law of sines. What two situations do you have to start with the law of cosines? There's only two.
Oh,
triangles.
Is it 45?
No, it's when you know the angle, say that's 30 degrees, and you know a side and a side.
Yeah.
That's a side angle side triangle. Well, I can't start that with the law of sines. I don't have, in order to use the law of sines, you have to have an angle and you have to have an opposite side. And in that picture right there, I don't have that. I've got an angle, but I don't know its opposite side. And I know two opposite sides, but I don't know their angles. So I cannot use the law of sines on this problem. The other problem that you cannot start with the law of sines, and I say that because you always use the law of sines, you just don't start with it, is when you have side, side, side. Again, I do not have an angle and an opposite side. I can't use the law of sines until I get that relationship. Once I see an angle with its opposite side, then that relationship holds for every angle in that triangle. And that's what the law of sines is. So we have to first of all figure out what we're looking at there. And the best way to do that is with a picture. It's hard for me to even figure it out. They're giving us B, that's 79 degrees. And they're giving us C, which is 45 degrees. And they're giving us little b, which is 32. Do we have a angle with an opposite side?
B.
Yes. Well, the answer is yes, we do. They'll almost always give you 3 pieces of information. And they want you to solve, in this case, they only want you to solve for side A, which is this side right there. But, so, what's the law of sines? The law of sines is going to let us solve that. What's the general law of sines? The sine of the angle over the opposite side is the constant.
Yep.
So that's equal to the sine of b over b, and it's also equal to the sine of c over c. In other words, once we come up with this relationship, we can apply it to every single angle and side. Well, we've got one here. I didn't mean to do that. But that's okay. We have everything we need. So we've got an angle and its opposite side. Okay? Yeah, let me draw this again because I kind of screwed it up by erasing it. There's B, there's C, there's A. This is what we're trying to solve for little a. So using the law of sines, what's the first thing I can do?
You can
start with the fixed relationship. We know this 79-degree angle, and we know its opposite side. So let's start there. The sine of 79 degrees divided by 32, that relationship is the same no matter where we look in this triangle. So it has to be the same as the sine of 45 divided by its opposite side, which is little c, which has to be the same as the sine of the third angle divided by little a. Well, in this case, it's real easy to calculate capital A. What's capital A?
It would be one second.
It's 56.
Okay, yeah.
Okay. So we don't need to do this step.
Yeah.
In other words, the fact that it was so easy to calculate angle A, we'll just go straight to this one. And now we've got this equals that. There's only one unknown in that equation. When there's only one unknown, that means we can solve it. Okay, so if I do a little cross multiplying here and dividing, I will get A times sine of 79 equals 32 times sine of 56. You see where I got that?
Yeah.
Okay, so A has to be 32 sine of 56 divided by sine of 79. Now remember, that's a number. So is that. So once I get it to this point, now you can, if they have to have an approximate answer, well, you can get all three of this from your calculator. In other words, put that into your calculator in one step. What do you come up with? Or multiple steps. You don't have to do it all in one entry. It can be a little tricky. You got to be a little careful.
I don't have my calculator with me right now.
Okay. Try to bring it tomorrow.
Okay, yeah.
You're going to need it. Okay. Always bring your calculator that you're going to use on the test. The same one. Okay. But this comes up with a number. Now, the only thing I know about that number is that it's got to be less than 32. Because there's a rule about triangles, is that the longest side has to be opposite the biggest angle, and the shortest side has to be opposite the shortest angle. Well, we're opposite the middle angle, so I know this number has to be less than 32. That's all I know. If I get something greater than 32, I've made a mistake. In other words, it's when you do a ballpark check. That's what I'm talking about doing. When you do a ballpark check, which is helpful when you're dealing with expressions like this, because when you go to put that into your calculator, if you happen to miss a parenthesis, you could get an answer that's off by a factor of 10. So if you got an answer here of 212, you know it's wrong. It's got to be less than 32. So go back and check your calculations again.
Okay.
Okay. All right. That's a good place to stop. And we'll finish up. Go ahead if you want and send me, or you don't have to now. You can wait and send it tomorrow because we'll still have this problem to work on. While we're working on that problem right there, you can send me your next sheet.
All right.
Okay. I will talk to you tomorrow at 3, Laughlin.
Thank you.
You're welcome. Bye-bye.
Bye.